my name's Will. I work at Neo4j, and what I want to talk about today is building GraphQL APIs backed by a native graph database to take advantage of the graphiness of GraphQL. So these slides, they have a bunch of links to the code and different resources, so you might want to pull those up. It's dev.neo4j.com/GraphQL SF. In addition to working at Neo4j, I've been writing a book, Full Stack GraphQL Applications, published by Manning. This kind of just shows how different pieces fit together in a full stack GraphQL application. This uses the grand stack, which is GraphQL, React, Apollo, and Neo4j database. So that's been my project for the last little bit. How many people have heard of Neo4j? Oh, sweet. How many people have used Neo4j? Okay, cool. How many people have used GraphQL with Neo4j? Okay, a few folks. Okay, cool, great. So Neo4j is a graph database. What that means is that the data model that we use in Neo4j, instead of tables or documents, the data model is a graph. And graph databases are optimized for working with graphs. So you have some different performance trade-offs that you have with a graph database compared to other databases. There are lots of interesting things you can do as well with things like analytics, graph visualization, these sorts of toolings. We use a query language called Cypher with Neo4j, so you can see an example here in kind of the upper right. And this query comes from the Panama Papers data set, if you're familiar with that, investigative journalism investigation from a few years ago. The investigative journalists working on this got a bunch of leaked data about offshore companies and people connected to them, and loaded that into Neo4j because you found this like really nested structure of like, okay, I own a company that owns a company that owns a company that owns a yacht in the Bahamas. Like who ultimately owns that? And a graph database is really good for that. So you can see in this Cypher query, we're drawing these sort of graph patterns with this ASCII art representation. So this is going to find all addresses nodes in New York, traverse out to find officers connected to them, and then traverse out to find entities connected. So you see we're sort of drawing like graphs with kind of arrows here with this ASCII art representation. Of course, like a database is not interesting by itself. It's really about what problems a database can solve, what tooling integrates with your database. So I like to look at this slide just to kind of show a look at the different pieces of the Neo4j platform and what integrations and use cases folks have. So there's sort of this spectrum from left to right of transactional use cases to analytics and data science. And when we're building applications and we want, say, a GraphQL API, that's firmly on the left side of this, so with our sort of drivers and APIs area. But I like this just to show kind of there's lots of things that people are doing with graphs. So let's talk about the graph part of GraphQL for a bit. So let's back up and just talk about graphs. So fundamentally, a graph is a data structure that allows us to represent data. We represent the entities as nodes, relationships, connect nodes. You may have heard the term property graph before. Property graph just means we can store arbitrary key value pair attributes on our nodes and relationships. And when we have an instance of a property graph, once we've loaded some data, seen how it's connected, well, then we have a knowledge graph. Knowledge graph is really just some graph that's putting things in context rather than just entities by themselves. I can understand, in this example, this comes from the New York Times. So we've pulled in New York Times articles. We know what topics are mentioned in the article. We know the people mentioned in the articles. We know what geo-regions they're about. So it just helps us to contextualize the data that we're working with. And this is a really good data set. I like to use this as an example. So for the rest of this talk, we're going to use data that comes from the New York Times API. I set up a little scraper. The code for this is on GitHub. Basically, we're going out to the New York Times API and fetching the most popular articles every day, and then load those in in a database. Just an aside, I do this with GitHub Actions using an action called flat graph, which is super cool because it allows me basically just to stick some YAML in a GitHub repo and set a cron to run once a day. Don't have to worry about it. It's kind of a handy, hacky way to load some data. Anyway, so we have data about articles, the topics mentioned in these articles, what georegions they're about, the people mentioned in them, organizations, this sort of thing. So imagine we're a developer and we're building a newsreader application. Maybe it's an iPhone app, maybe it's a web page, whatever. We have this knowledge graph of our news articles. How do we want to query this data from our newsreader client application? Do we want to use GraphQL? Well, we have this data in Neo4j. Do we just query the database directly using Cypher? There's visual tools for querying graphs. Like, what does this look like? So let's take a look at a couple examples. First, we'll start with GraphQL. So GraphQL, we're at the GraphQL meetup, so I'm not going to go into super overview of what GraphQL is, but fundamentally, GraphQL is a query language for APIs. So a GraphQL API for our news data might look something like this. Actually, this is running live. You can play with this, news.js graph.vercel.app. This is GraphQL Playground, so we can see the query fields, the entry points, so we can search for articles, search for people, and so on. Here's a query that I ran earlier, so we'll just start with this. So this is articles, sort by publish date in descending order, give me the most recent 30 articles, and then in my selection set, I'm pulling in things like the title, the URL, but then we're also finding any photos connected to the articles, people mentioned, and so on. So you can imagine how we would use GraphQL in our client application to fetch data this way. If you're familiar with GraphQL, this should look pretty familiar. But another way would be to use this Cypher query language that we just looked at to query our data. So maybe we want to show the most recent articles and the topics. And if we want to show, recommended articles, here are other articles of the same topics you might be interested in. So for that, we'll use a tool called Neo4j Browser. So I have a Neo4j instance loaded with this data. Here's an example query. So we saw earlier this like ASCII art representation of the graph that we're sort of drawing. So parentheses, wrap nodes, we draw these sort of arrows to define relationships. So this is saying find articles that have topics and give me the 25 most recent sorted by publish date in descending order, right? And we get our articles, we can see here's the detailed information, so the abstract, the author, the URL, we can see the topics. We can expand out to find other nodes of these same topics. Okay, if you're interested in, what was this one? US politics and government. If you're interested in that topic, here's other articles you may be interested in, and we can sort of traverse out from there. We can do this either in Neo4j Browser is kind of like a query workbench development tool, so we could add to our pattern here to define more complex patterns, or we can just kind of double click around to explore the graph. So that's another approach for querying our data. Another option would be using visual tools. This is one called Neo4j Bloom, which if you're not a developer allows you to kind of use natural language search to visually explore the data. But we're developers, we're building a serious app where we don't have any use for that, so we'll skip that one. And we'll just look at, let's compare Cypher and GraphQL a bit here. So Cypher, we said, is a database query language. We use this declarative pattern matching. We draw this ASCII art representation of the patterns we're looking for. And in Cypher, we have the functions that you would expect from a database query language for doing things like aggregations, math functions, database operations like creating indexes, loading from CSV files. All this stuff is built into Cypher. But then because it's a graph database query language, we have graph-specific operations for things like finding the shortest path or variable length path operators, working with nodes and relationships, these sorts of things. If we compare that to GraphQL, Well, we said GraphQL is a query language for APIs and a runtime for building these APIs. We model application data as a graph with GraphQL, and GraphQL is really data layer agnostic. So we can build a GraphQL API on top of any database, any other API. We can combine data sources and these sorts of things. And we have a similar idea of this traversal through the graph with the nested selection set. If you've created sort of these nested selection sets, maybe you're going from the article to the topic to other articles and so on, just by creating this nested selection set, that's just describing a traversal through the data graph. So let's look at some questions that we have and see how we would approach that using Cypher, how we'd approach it using GraphQL. So first of all, show me all of the articles. Well, with Cypher, we draw the graph pattern that we're looking for. In this case, it's wrapping article nodes. This article here is called a label, so it's kind of like a way to group nodes. And we say find all the articles and return them. In GraphQL, it might look something like this. We have an articles query field, that's the entry point. And then in our selection set, what do we want to bring back? Maybe just the title and abstract to show on maybe like the landing page for our app. If we want to find the 10 most recent, well, Cypher has pagination, ordering, sorting, this sort of functionality. This is not built into GraphQL, but of course we could represent these sorts of things as field arguments. So the GraphQL API we built for this, we have a sort field argument that takes the field we want to sort by in the sort order and the number of objects to return. So that's fine. Now we want to see the 10 most recent articles and the topics associated with those. This is a little bit more complicated than what I was showing before because, well, we may have articles that don't have topics, so we have to use this optional match. And you can see here, this sort of orphan node here doesn't actually have any topics, but we still want to capture it. So we just add an optional match, but then we just describe that pattern we're looking for using this ASCII art representation. And to do this in GraphQL, well, we just start adding to this nested selection set. So now we add topics field, and then we want to bring back the name of each topic. Now we want to go from the article to the topic to other articles, so a little more complex traversal. Well, in Cypher, we just add this part, so it has topic article now to the pattern we're looking for. And in GraphQL, we just continue nesting our selection set. Now we've added going from topics now to articles, the title of those topics. So we're getting the most recent articles, the topics associated with them, and other articles that have those topics. What about something a bit more graphy, though? What about the shortest path from connecting two nodes? So here we're looking for the shortest path from the National Park Service to the FAA. And in Cypher, we said this is a graph database query language, so we have graph functionality in it. So we have a shortest path function. We have this variable length operator. We can just put an asterisk in those brackets to say, find where this path exists in the graph, however many relationships you have to follow to find that, where these two nodes are connected, and then find the shortest path. In this case, we use a depth first search to find that. And we can see here that this node on the left is the FAA, the one on the right is the National Park Service, and they're connected through this topic of shortages. There's a couple of articles about how both of these organizations are short-staffed and so on. GraphQL doesn't really have this concept of shortest path. We would, of course, like build this functionality and expose it through a GraphQL API, but it's not something that's built in. What about finding recommended articles? How would we do that? Well, maybe if you're reading an article, you want to find articles that have similar authors, topics that are about the same geo-regions. So we can express that in Cypher using this pattern here. This is just saying find nodes, find other articles that have overlapping either geo-regions, topics, or authors. GraphQL, again, doesn't have this built in. We could, of course, build that into our API and expose that, but it's not something that's fundamentally built into GraphQL. So now going back again to this question of, okay, what does the architecture for our app look like? Are we going to query the database directly? Are we going to query GraphQL directly? What does this look like? And hopefully it becomes a little clear that our architecture should probably look something like this, right? We want our GraphQL API to sit in between the client and the database. We don't want to just expose our database to the world. We want to be able to implement things like caching and authentication for our app at the GraphQL layer. And also gives us some idea of what sort of functionality is available in Cypher and GraphQL. So then the question comes up, okay, well, how do I build GraphQL APIs with Neo4j? And of course, we can implement resolvers and write sort of boilerplate data fetching code to do that, but there's an easier way to do this using the open source Neo4j GraphQL library. This is a JavaScript library that makes it easier to build Node.js GraphQL APIs backed by Neo4j with a lot of auto generation and a lot of built-in functionality. So some core principles of the Neo4j GraphQL library are GraphQL first development. So the idea is we define our type definitions, and this drives the data model for the database. So I don't have to manage a schema for the database and a schema for my API. Both of those are driven by GraphQL. The Neo4j GraphQL library then takes those type definitions and generates things like query and mutation fields for every type, things like ordering arguments, pagination, complex filtering, these sorts of things to give us a fully functional CRUD API. And then the thing that is really, really neat is we don't need to implement resolvers. So we don't need to write boilerplate data fetching code. We're able to generate database queries from arbitrary GraphQL requests. So that's sort of CRUD functionality. What about custom logic? Well, we can actually combine Cypher with GraphQL in our type definitions with the Cypher GraphQL schema directive. So schema directives are GraphQL's built-in extension mechanism that allow us to say, hey, there should be some custom logic here. And in this case, we're basically binding a Cypher statement to a field in our GraphQL API. So in this case, we have some custom logic for finding similar recommended articles defined using Cypher. So this little snippet on the left here, this is kind of the minimum viable snippet for building a GraphQL API with the Neo4j GraphQL library. And the big thing that jumps out is there's no resolver functions. Everything is driven from type definitions. We create an executable schema, pass that to, in this case, Apollo server, and we're done. So let's look at a demo of this really quick. This one. So if this is just a code sandbox, you can click this and it points at a database that's already running, the same one we were querying earlier. So we can see our type definitions. We have article, we have author, we can see how they're connected. We can see we're using this relationship schema directive just to define the type and direction of the relationship so that we're able to kind of keep the data model that we use in Neo4j synced to what we use in GraphQL. And here's a super simple GraphQL query that we'll run to find the most recent articles. And in the logs here, we can see the Cypher that's generated. Basically, we're just matching on articles and just returning the title. If we add more complex info, like here, let's get the people mentioned, their name. We can see that the generated Cypher query now includes that traversal, and those fields we're returning as well. And if we add our similar field, we can see in the generated query now this query that we attached in the Cypher schema directive, which is down here. So here's our similar field on article and our Cypher statement that we defined in the schema. That's now included in our generated Cypher statement as a subquery. So we're still generating a single round trip query to the database. So this addresses the n+1 query problem if you run into that, even including our custom logic. So a lot more to the Neo4j GraphQL library, things like authorization built in, and so on, but it's a really, really great way to get started building GraphQL APIs with writing very little code. If you're interested in how these sort of database integrations for GraphQL work, basically the generator resolvers grab the GraphQL resolve info object, which is passed to every resolver, this resolve info argument here, and there's a ton of information that's available inside each resolver, so you can basically look at the GraphQL schema and the query to sort of build your database query from that. I gave a talk at GraphQL Summit that goes into a lot more detail of how this works, if you're interested in that. So we looked at building a GraphQL API sort of when we don't have a database. We use our GraphQL type definitions to drive the database, but if we have an existing database, we can also generate a GraphQL API from that. There's this really cool GraphQL toolbox tool that sort of visually allows us to just point this at a Neo4j database, infer the GraphQL type definitions, and then it has some querying functionality built into it. So that's a good place to start as well. Cool, so I'll just mention a couple of resources if you're interested in learning more here. One is the landing page for the Neo4j GraphQL library, which has links to the docs and examples and all of that. There's also Graph Academy online training to check out as well. If you're interested in learning more about Neo4j, there's a free cloud service, Neo4j AuraDB, that has guided examples to kind of walk through that as well. And so since everyone raised their hand when they said they built something with Neo4j earlier, if you're interested in sharing what you've built at our online conference, that is coming up. Nodes is coming up, which is the Neo4j Online Developer Expo and Summit. The CFP for that's open, so definitely check that out. Just links to the code and all of that as well. Cool, so I think we're out of time, so we'll skip questions, but if you have any questions, just find me after and definitely flag me down and we can chat more. Thanks a lot.